case studies from Data Reply. We're going to do an event about operational research, data visualization, TensorFlow, and data governance. Those are the topics that we will organize next month. So if you are interested on hosting one of those events, there are great benefits. So you just speak with me or one member of the staff, and we will be more than happy to bring the community in your house. If instead you have something you'd like to propose as a talk or some topic you would like to discuss, there's a call for speakers. You'll find everything on the website. Don't be shy. So we are creating, managing this database for next speakers. And even if you don't want to speak now, you'd like to register as a potential speaker for next year, then please send your application. Now, just a little bit of promotions of our partners. So there is one free course on data science happening here in Milan. It's for students and fresh grads. So if you're interested, you can apply before the 12th of October. There's one of the startups of our network, which is looking for a CTO. They are building a meta search engine for travel activities. If you're interested or you know anyone that would be interested on that position, then please come and speak with one member of staff. If you'd like to receive one free ebook copy of Python Deep Learning, there's a review referral scheme where you get the free copy and then you ask to leave a review on Amazon. Again, speaking about member of staff. There's another important communication that I'm not going to give you any review, but Alessandro will spend a few minutes after this opening, and it's about the task force of artificial intelligence. Now, sponsorship. So everything you see here, all of those events, all of those initiatives can happen thanks to our sponsors. So without sponsors, we wouldn't be able to be sustainable. So Open Search Network is our endowment sponsor. It's a headhunting company specializing in data digital experts. So if you're looking for a job or your company needs to hire professionals of data science, then I strongly recommend you get in touch with Open Search. There are a few different packages. If you like to become one of the sponsor, it goes from the basic packages up to the exclusive package where you get essentially promotion all year round. You can associate your brand with the Data Science Milan brand. You can have a feature contents, data analytics can be exclusive from competitors and so on. There's a lot of benefits then speak with one again. If you're interested, then please come and speak with me. This is the essentially the roadmap. We like to find one big sponsor for each industry. So far, we found on recruiting, we're dealing with a tech consulting company, and we are looking for a telecommunication company, a bank, manufacturing company, education like university, retail, energy, and insurance. Those are the major industries we like to fill. And yeah, so that's it. So if you just a visitor or a guest, then I hope you will enjoy this event, and I'll invite you to join us on datasciencemilan.org. This is the agenda for today. We'll have a very quick it's a call for action of this artificial intelligence task force. Then we'll have an introduction of data science in Pirelli from Carlo Tognai. Then we'll have our guest speaker and also sponsor of this event, which is Nick from Domino Data Lab. And then we will finish with a use case of Pirelli using Plotly and Domino for smart manufacturing. It's going to be a guided tour of the museum. We'll all gather outside here. We'll be split into two groups. it will last around 30-40 minutes. And then when you come back, we will arrange a buffet here. Okay? So it's very important because we need to be known. We need your contribution to share what we hear. Don't be shy, post it on the okay? Thank you very much and enjoy your night.
Hi everyone. While John Mario changes the PowerPoint, I'll introduce myself. I'm Marco and collaborate with John Mario and the staff members for the improving of the data science Milan. And so as John Mario said, what we are building is a community that also come to tech talks, but also participate a lot. So our next step is to make the community more participative. We have done it with the Slack channel. We have done it with the website and opening a Facebook page. But next, we want to organize a panel discussion, which we can communicate and interact. And our first attempt to do this is with the task force of AI. Alessandro now will talk us a bit more about these initiatives, and we hope to organize a few events to discuss about this good government initiative that is happening now in Italy. And so keep in touch and participate in next events. Thank you.
Good evening, thanks to the organizers. My name is Alessandro Vitale. I'm a founder of a couple of artificial intelligence companies, but tonight I will talk to you about Artificial Intelligence Task Force. It's a team established by Agenzia per l'Italia Digitale, which is a government agency. Last April, there was a public call for experts. They received more than 500 CVs, and out of that, they selected 30 experts, which are now working for free to as the coordination board of the task force. The background of it is very diverse. Most of the coordination board comes from academia, but there are also lawyers, people from public administration, and some from the private sector like me. We met the first time last September, on September 7th, and the first goal of the task force is to write a white paper in which there will be a sort of overview of the state of the art of artificial intelligence in Italy, and start providing recommendations to the government on how the public administration take advantage of artificial intelligence. So the goal now is to have this white paper coming out in December. And we are doing this in the open, meaning that there is a website in which there is the index of the white paper, which everyone can comment and work upon. Then yesterday was the deadline for our board to provide contents. So in the next days, it will be on and it will be open all the drafts of the white paper. And the community can contribute, make comments and change it. And there is also a forum in which you can write links or suggestions. And then after the white paper comes out, another goal is to do some pilot projects in public administration. So start doing some artificial intelligence projects with the local or central government to see how it can be done inside public administration, and then take advantage and do more ambitious projects. If you'd like to contribute, there is a website which is ia.italia.it, or AI for the English version. There is that's the link to the community, and also you will find a link to the document that is being written, in which you can contribute. But we are also, next Wednesday, we will meet for the second time in Rome, and we will also discuss how the task force can interact better with the community. As Marco was saying, we will find ways so that if you meet and share ideas, all your contributions as a community can be integrated and put into the task force works. If you have any questions, I'll be around after the event. we can discuss it. Thank you.
Hi everybody, I'm Carlo Torniai from Pirelli. Thank you for coming, first of all. I'm going to give a very high level and brief overview of what we do, what we're trying to do here in Pirelli. Most of the people you see around, Alberto, Gianmario is working in my group. I'm not gonna, Alberto then is gonna talk a little bit more on some technical stuff that we do as part of manufacturing, but I'm more on, the give you a high-level overview of our group, of what we do, and the philosophy. Well, you shouldn't know, well, a little bit about me, why and what we're doing, and what is our approach in Pirelli. I try to be very quick, then we can, if you have questions, we can talk later on, because I want to give the space to Alberto and Nick for the actual me. So, well, you don't need to know a lot about me, except that I find my career going back and forth from academia and industry, bunch of interesting stuff. Prior to Pirelli, I was at Tesla, and now I'm here. Pirelli, well, most of the audience is Italian. I think Nick knows us, but you know, the fourth largest tire manufacturer. We have targeted the premium segment. Who is not into car, maybe into fashion, and so you may know us for the calendar. Why and what we do in Pirelli? What about data science? Why we started data science group in Pirelli in the first place? So, well, besides the obvious answer, 125 years, some data collected in the manufacturing company. So capitalize on the amount of data that we had. Of course, trying to switch a little bit of, being a traditional manufacturer, we want to move into the service space. And data science was, and data basically was the trigger to move into the space, but mostly was the initial brick, I would say, to drive a cultural change. Nowadays we call it digital transformation. I want to say just cultural change because it's way better and more, I think, representative of what we're trying to do. And so Pirelli decided to start from that block to drive this change. I joined the company 2 years ago, and well, I'll give you a little bit. Now we are about 20 people. I was by myself back in 2015. We work in many areas. You have 3 main clusters of activities here. Today, Alberto's gonna talk a little bit more about the first one, as well, manufacturing. But also we work on trying, to make our standard process more open, data-driven, API-driven, and build kind of hopefully algorithmic value chain across the company. We started for the demand forecast, which is one of the main thing that we focus in. Also on the service side, you may have heard about this digital platform called Connesso, which is is a sensor tire that streams data through a central unit to your mobile phone, giving you the condition of temperature, pressure, but also computing tire wear, the start of wear of the tire. And we're launching in US in 2 months, and there's the part that has a lot of more data science involved and a lot of cool stuff happening on the service side. Just on the smart manufacturing, just a little bit of overview of our roadmap, because we started, 2017 should read also from 2015 on. We mostly focus on a lot of visual analytics because it was the easiest way to bring value to the factories, and so have the capability of people on the floor to see the start of a machine, do some prediction on how the process is going to be, what was an easiest way to add value to the process. And also, we spend a lot of time trying to build a data-driven culture across the company, but also in the factories, meaning tools and means to people that actually know the process, know, for instance, a production machine, to interact with the data coming from the machine. So not turn everybody into data scientists, but at least build a culture in which you're used to interact with data, a different level, from the CEO to the guy in the factory. Then we start building more and learning a little bit of predicting stuff where we are right now. Alberto is not going to talk much about that, but a little bit. We are now entering the realm of predictive maintenance, and our final vision is, what we call virtual factory, which is not just, accessing anything in the factory from anywhere, which is something, by the way, we already can do, but also also have the sense of a machine-to-machine, machine-to-human interaction to have auto-regulation of process and automatic alerting and correction of production pipeline. This is the high-level overview. I don't go much into detail. Alberto will show some particular use case in which we use Domino. Then Nick will explain. But if you have questions and you want to know more, just come see me afterwards. I just want to spend a few words on how they approach, because I think besides the tech part that you're going to hear, I think part of the challenge when building a data science team, in particular in a 125 years old company, is how to approach it. And it's not. I mean, there have been attempts before our team started to use technology or deal with data or do some analytics or some predictive stuff. And what do we do differently, respect to what was tried before? But first of all, the three axes I want to very, very brief touch with you is that how we approach people, process, and technology in creating our group. Let's talk about people. First of all, we started outside the classic company grid. We were a small team. Actually, I've been for a few months just by myself and organized like a startup. A little bit of the guy with the Mac on the corner. We don't know what they're doing, but they're doing something. And so outside of a little bit of usual function, no reporting to IT or CFO, we had just one straight line to the CTO and basically license to kill. Do whatever, do something. And that, I think, was a good way to start. The second, we decided I wanted to attract talent. I wanted to build a core competence team rather than start working immediately with outsourced firms. And so the idea is to start. It was the hardest part, and probably if you're in the field, it's not easy to attract, hire, and retain talents, in particular in this space. In particular, it was even harder like 2 years ago. The idea is, again, build a very diverse group of people. Well, here's a picture of like last year where we're doing an offsite doing canyoning. We've grown more of that group, but you can see Gian Mario there, some Alberto. They're still alive after that. And our idea, diversity in terms of backgrounds. I didn't want just computer scientists. I didn't want just physicists. We have like linguistics, people coming from biology and stats, computer engineer, computer science, mathematical engineer. Diversity in background helps to do the job that we do. Also, I kept the organization very, very flat and small, and as much, let's say, independent. Try to be something that you can build a data product end to end. In fact, our team has grown from a core data science team up to data engineers, then front-end developer, back-end developers, user experience design. So we are now growing like a small engineering factory in the company, and we enlarge our scope. Okay. Then process. This is kind of very important. We started adopting Agile methodology not just because it was the cool thing to do, but the foundation of values, which for me, transparency and trust was the way to work, not just with the team, and is the way to work, but especially outside in the relation to organization. So these are the pillars in which, even particularly for the job that we do, where you can really do things that fail. By definition, you may try a model, you may try exploratory data analysis, you're not sure of the results, you need to be in an environment in which you really are safe to speak the truth and say, hey, we did this, it didn't work. And if you're not there, you're gonna, sometimes down the road, you're gonna have issues. So for me, that was really important. And try to break, the usual contract game between business and whatever service providers that are there. These are the specs, you give me what I want. No, build teams that work together, cross-functional, and we're all together and make it work. And this is the only way, as I said before, in which you can deal with uncertainty that comes from the kind of work we do. And also, again, expand across. You don't want to be you move from the strange guy with the Mac to a team that is actually embedded in the business and more product focused and product centered, customer centered. Last thing, technology. Well, it's never the first part, even though we have Nick talking about that. And it's never just about the tools at first. For me, the most important stuff was using the right tool for the job. And so, I've seen people studying for building the perfect infrastructure first and then trying to do data science. We can debate. I don't think that's the approach that actually works. First, you need to understand what you want to do and see what you want to do, what is the best way to do it, and even start with what is available in a company. You can't wait to have the perfect data, it never happens, or the perfect infrastructure, the perfect computational stack to do what you have to do. You have to do incremental cycles and iterate even the technology you're using. And so choose the right tools at the right time. I think I'll stop here with 1 minute before the time, I suppose, just to introduce these. Speaking of tools, I had to tell you a story how we met and how we started to actually work together. Well, it was some years ago, let's not say the date, not that much, but a few. I was doing a boot camp in San Francisco about data science, and Nick came to give a talk about the really embryo Domino company that he was funding. And he gave us such a demo to try. It was nice. Yeah, it passed. A few months later, I was starting working at Tesla. And one of the main issues we had, I was working in, it's called the Product Excellence Group, and we were responsible to hold the whole analysis of data coming from the field, from the cars, from the sensors, and also, from the product experience. So we were dealing with a lot of factory data, field data, but also service data. And one important thing, especially for the legislation in US, is if you say that a particular component is reliable, has a warranty, you have to produce and be able to reproduce the computation you did in order to either predict a failure or assess the reliability level of that component. So I started to build a system in which we should, reproduce every single analysis as a data science team we did. And then I remember when I was talking, I had like 4 data scientists, and we're starting mostly doing like software development part. We're studying, okay, then I need to do the stack. I used to version everything. And then I remember that Nick said, wait a minute, but they kind of doing what I'm trying to build. Let's get in touch. And then I talked to Nick, and then we start collaborating and using Domino. Just because, as a data scientist of very few people, I'd rather work on data science part rather than on the infrastructure part. And when I was starting, building that part, we start collaborating, and here he is. So please welcome Nick Alprin, the CEO of Domino Data Lab. He's going to talk about what you got.
Thank you so much. So I need to share my screen through this. Let's see. I'm gonna.
Okay. Yeah, you should be able to do that now.
Yeah.
Yeah. All right.
Is this working? Okay. Let's see this. I've got a new fancy MacBook, which doesn't have the right connectors. So I'm going to drive here, and then I'm screen sharing here, which is plugged into the monitor. We'll hope this works without too much lag. Great. Yeah, a little delay. That's okay. And I'll probably sit at some point to drive here, but I'll start by standing up. Thanks, guys, so much for having me. I've been working with Carlo for the last 3.5 years or so at Tesla, now at Pirelli, and it's great to be working with him, and it's great to be visiting you guys in Italy. I landed this morning from San Francisco, so apologies if I start to slow down a little bit due to jet lag, but I think I'll power through. I had a double espresso this afternoon. I'm going to talk about lessons learned from working with advanced data science organizations, and this is not going to be a technical talk for the most part. I know you guys get lots of those, and how to use TensorFlow or how to use whatever the latest packages and tools are. This is going to be a little more in the style of a TED Talk, and I'll move pretty quickly through some high-level points and concepts. Then I'll jump into what will be a shameless pitch for our products. But I will connect that demo to some of the bigger picture topics and concepts that I've been talking about first. Let's see. I want to do 2 things here. I mean, the first is seed in all of your minds to give you something thought-provoking to take back to wherever you work about, like I said, sort of some concepts or some ideas that you might be able to apply to the organization that you work with. Not so much about technology or a particular tool, best practices and processes for enabling more scalable data science practices. And then I'm going to share a strategy for how to implement some of those ideas. And like I said, I will talk about our product and how it sort of implements those strategies. But even if you have no interest in our product, I want to leave you with something valuable you can take back. Quickly about me, I started building Domino Data Lab about 4.5 years ago. We now work with about 100, mostly in the United States, but also out here in Europe and a couple in Asia. And I've been really fortunate in that position to get exposed to a lot of different teams and problem domains and get a sense of how they operate. I was in the finance industry. I worked at a big hedge fund, and I ran an engineering team there that built all the internal technology and products for data scientists at that hedge fund. And I have a background in computer science. So I was sort of an engineer by training, and then started building products for data scientists, and then now I've turned that into a product. Okay, I'm going to jump into kind of the lessons learned from advanced organizations. So the first thing that I notice all the time, a lot of data scientists think of their work as a solo job. They are a brilliant practitioner. They sit down, they do their work, they do their magic, and then sort of insights and models come out of that. The most effective organizations that we've seen in those organizations, data scientists view their work as contributing to a collective whole. And I think about this as, how does a company create a culture where they view their work as building a hive mind? So if one person knows something, then that knowledge becomes shared throughout the rest of the organization so that people don't have to reinvent the wheel or rediscover the insights that other people have had. And so the beehive image here is meant to sort of evoke that metaphor. One of the things we see a lot, just to make this concrete, oftentimes data scientists or teams will finish a project and they view their job as building a model or building a report or answering a question. And the best teams we've seen, that's not what their job is. Their job is to do that, and then when that's done, leave that work, leave that knowledge they've created in some state where other people in the future or other people around the organization can pick it up later and build upon it and benefit from it. So your job is not done until the rest of your organization or the future employees on your team can benefit from the work you've done, and that will make for a faster pace of scaling your organization. The next thing that we see, do these in a series of contrasting statements, we often there's sort of this notion in popular culture that insights come from these breakthrough aha moments or these epiphanies. And this is Isaac Newton sitting under the apple tree, fell on his head, and he had this realization about gravity. Well, in reality, that's not how it works, and that's not how the best organizations are built. They're not built around that notion. And what we find in practice is that real progress, real breakthroughs come from lots of small insights that compound over time. So every day people are making things just a little bit better, and just like compound interest, if you have money in a savings account, each of those incremental improvements build upon themselves and lead to a big result over time. And even Isaac Newton actually said, if I've seen farther than others, it's by standing on the shoulders of giants. And this is this idea that new projects, new data science projects never start from scratch. They never start in a vacuum. And just connecting back to that point about the hive mind, how do you equip your organization to be able to take advantage of all the past work and learning that have been done before? Next point we see a lot, and this is certainly something Carlo touched on, we hear a lot of organizations looking for these silver bullet tools and technologies, for the latest big data storage solution, the latest visualization, the latest package where we'll just upload our data and it has pre-built models that are going to automatically figure things out for us. And in reality, especially because the state of the art in the space is changing so fast, what's more important than any one particular tool is having the agility to rapidly experiment and test new tools, new techniques, to take advantage of whatever's coming next. And a lot of them won't work, some will work, but sort of as your organization geared to be able to take advantage of that. In contrast, we see a lot of organizations where there are somewhat stifling IT departments that make it hard for technical people, for data scientists to get access to new tools and packages that could be valuable to experiment with. And then the final contrast that I'll draw, somewhat related to the tools, the tools notion. Oftentimes we see leadership, senior leadership, senior executives, especially if they haven't come from a technical background, have this notion that technology is sort of like magical, that technology will solve all the problems, and that you just throw technology at things and that makes things better or faster. And if just extrapolating from some of the points I've made so far, what we've seen is that really the secret sauce or the key to rapid innovation and progress in an organization is not first and foremost technology. It is having a culture of discipline, rigor, rapid iteration, constant improvement. And it's these things I was talking about around how do you enable more collaboration? How do you enable more reuse of past work? How do you enable faster experimentation and the ability to build upon past learning instead of reinventing the wheel every time? And if you think of this as your goal, how do you create an organization that works this way with this discipline? Then we think kind of the best that technology can do is actually enable. So how can technology enable this kind of way of working? How can technology enable more collaboration, faster iteration, more discipline, more rigor? So I think you know where this is going. That's sort of what the idea is behind our product. I'll elaborate a little bit on these points though. Stepping back, if you just to synthesize a couple of the themes I've touched on. The first one is around collaboration, and that means a few different things. That means, how do you enable a shared context? This is like when I talked about the hive mind idea, instead of having individuals working in silos. How do you make sure that if one person is working on something, other people know that without elaborate process to go through? How do you make sure that if one person has a better idea, or if one person improves a core component, other people are able to take advantage of that? Discussion is a big part of that. Search and discovery is a big part of that. Maybe all these great ideas, all this work other people have done are out there, but if nobody knows to look or nobody can find the work that's been done, then it's not really creating value in the organization. The next theme is around reproducibility and reusability. And software engineers have solved this problem. They solved it decades ago. They figured out, okay, we need version control, we need build systems, and build systems have artifacts that link back to what version of the code we actually compiled. It's a little different in a data science context, and some of those tools don't transport perfectly to data science work. And that's because in data science work, it's not just about having the source code. You need the data sets, you need the results that got generated. What were the performance graphs and curves, and maybe the models that we actually trained. And we need a notion of what were the actual, if we want to really reproduce something, what were the packages that we had installed? What were the versions? It's not enough to just have source code. But having this ability to reproduce and reuse past work is key to enabling what I described around building upon what's been done before, standing on the shoulders of giants instead of reinventing the wheel all the time. And then the third theme here is around agility and speed of iteration. And that actually, there are two versions of that, two flavors of that. The first is during the R&D phase of data science work. How do you more rapidly, maybe those new ideas, maybe you want to test new tools and packages, how do you get them into your organization quickly? Things that are computationally intensive, and you need access to scalable compute, burst compute, to try more experiments at once instead of waiting a long time. And what we found is that it's not about one person having one brilliant idea and building one great model. It's about how rapidly can you test and iterate and experiment. And then the second version of this notion of iteration is actually, okay, you build a great model, you build some great analysis or dashboard. How do you get that deployed or exposed or shared with business stakeholders, with existing IT systems in your organization, so that great work that you did as a data scientist actually connects into the business processes that are driving decisions in your organization? And iteration there is important because oftentimes that last mile can be a real bottleneck. You can build a great model and then it can take 6 months to get it really deployed out to impact production systems. So there's iteration, speed of iteration when you're testing ideas and building models. And then there's speed of iteration when you build a great model. How do you get it deployed to the business? And often, if you're doing both of those loops really quickly, then the pace of progress in your organization will accelerate. So that's kind of my take on some recurring patterns and themes we've seen. There's a strategy we have pursued to address a lot of these problems nicely together. And like I said, even if, regardless of with our product, I think this strategy, this approach offers something valuable to take back to where you guys work to think about how to build adoption of some of these best practices. And that strategy is to find a way to incentivize best practices instead of mandating them top down. This is I show this slide and most people come up to me afterwards and realize they ask what it was, and I realize it's not that clear. This is a cupcake. Obviously, on the cupcake there are pills like medicine, and the idea is, how do you give data scientists something they want that gives them some instant, immediate gratification, and in the process of getting them to consume that instant gratification, get them to sort of take their medicine or do something that's good for them in the long run. And in this case, in our case, what we found is that you can give data scientists a central, sort of a central platform where you can automate infrastructure, you can make it easy to use new packages, you can let them scale their infrastructure and compute environments, and that makes them much more productive. That lets them scale their accelerate their experimentation, test ideas a lot faster. And the flip side of that, because they're using a central platform, what you can do is you can start to layer in these best practices. You can track their work. You can make their work searchable, discoverable. You can layer in discussion features in that central environment. And I contrast that to trying to force data scientists to use version control or a wiki, Confluence. And sometimes that works and that's great. But oftentimes when there's a top-down mandate, you say, you guys all have to put your work over here. If there's no incentive, if there's no short-term incentive, then people won't adopt those best practices. So this is how we've tried to encourage it. So I want to do a quick demo. Do I have time to do a quick demo? Okay. I want to do a quick demo, and I'll show you how we have implemented that strategy. Our product is the Domino platform. It's a data science platform, and it combines three things in a sort of a tightly packaged way. The first is a workbench that lets data scientists spin up compute environments, run common tools like Jupyter or RStudio, and also run batch experiments and model training tasks. And we automate infrastructure, and we make it easy to manage packages. So ops, and you can test more ideas faster. On the right side of this, we let data scientists package up and deploy the work they build so they can expose it to the business stakeholders more rapidly. We let them do that as publish things as APIs or as scheduled reports and apps and dashboards. And underneath all that, we keep everything in a central place in a collaboration hub. So there's discussion, there's search around past work, there's knowledge management. And these things together sort of implement what I was describing a few minutes ago. So let me do a quick demo. I'm going to sit down for this. Okay. Let's see. All right. This. You guys still hear me?
Yeah.
All right. So.
Yeah, increase the font, maybe, you know, kind of.
Oh.
Yeah.
How's that?
Yeah.
One more?
Or reduce the resolution. Yeah.
Is that okay?
That's better. Yeah.
All right.
A little bit.
There's a web interface, and to start out, you sort of just get files in here. So you can upload files from your computer. There's nothing special about the files we track. You don't have to move your work into some new format or migrate anything. And look, this can be scripts, this can be notebooks. We know how to render lots of different kinds of files. A quick show of hands. How many people are Python here? How many people are R? Good. Okay, you guys, you don't want to sit on opposite sides of the room or anything. So I'll sort of show something in both. But yeah, anyway, lots of different kinds of files or whatever you normally have in your project. What I have here, beyond sort of the files, when you're working in a project in our platform, we have a whole execution infrastructure behind the scenes here. And so let's say you're going to do some work, either you're going to use Jupyter or RStudio, or you're going to run a Python script or an R script. We let you choose where that will run, what kind of hardware to use. And we can do this in the cloud, we can do this on premise. So, you know, with one click, you can say, I want to take advantage of a machine with a lot of memory, or maybe I want to use a GPU. I'm going to do something with neural nets. For this demo, I'm going to use our cheap machine. And the other thing we let you do, we let you define and centrally store and manage what we call a compute environment. This is the set of all the packages and configuration that you need for your analysis to run. Under the hood, we use Docker. You can customize what's installed in your Docker images. These are a bunch of ones in a demo environment, but you make these yourself. And the idea here now is that anybody working on this project, because you can have your collaborators and your whole team works on it, instead of having to get their local environment set up properly to match what you did, that's all stored in one central place. So if someone joins the team, they come back later, it's all set up and ready to run. And now when you set up that infrastructure, you've chosen what you want, you've chosen your hardware, you've chosen your software, you can spin up these interactive sessions or run experiments. And this is the workbench I was mentioning earlier. So with one click, I can say, I want to fire up a Jupyter workspace. And what we're doing here is we're spinning up a machine of whatever hardware type you asked for. We're launching a container on that machine with the packages you want installed. We're linking your project files in. And so, you know, if I had chosen a big GPU or a high memory machine, that's what I would now be logging into. And then we'll just drop you into Jupyter. It's the same environment you normally work in, but this is kind of running through our orchestration layer. So when you make your changes, you can then save your work or get rid of your work, and then it'll all be committed and saved and revisioned back in your project so your colleagues can benefit from it. Works the same way with RStudio. So I'll say I want to fire up an RStudio environment. We'll launch a machine. You know, multiple people in your organization can have their own work going at the same time here. We'll elastically spin machines up and down. So Jupyter, RStudio, we support a bunch of other interactive tools if you want. The next thing that we do here is we actually let you run not just these interactive tools, but sort of batch scripts and experiments. And what I have here is a Python script that I took from the Scikit-learn website. And this does some topic classification of Reuters articles. I'm not going to go through all this. It trains reads a data set, it trains a model, it generates some plots to show how the model performed, it generates some statistics, like what was my AUC and a p-value, and saves them off to files and disk. And so it's all plain Python, nothing Domino specific here. Now what we can do is we can say, you know, I want to run this. It takes a parameter, like how large of a training set should I use? So I'm going to kick off this experiment. And, you know, while that's running, maybe I want to try a different idea. We talked about speed of agility, speed of testing ideas and iterating. So maybe I have two different variations of this model I want to run with different hyperparameters or different techniques. What I did is I kicked them off in parallel, and we actually spun up two different machines. And I could do this 5 times, 10 times. So now the speed at which you can test ideas gets much faster. You don't have to serialize your experiments. And remember I talked about a strategy of automating best practices or incentivizing best practices. Well, this is a great example because from a data scientist perspective, we just got a massive speed increase. We didn't have to deal with DevOps. We could test more ideas at once. But what we've done under the hood, every time an experiment runs, anytime you work in Jupyter or RStudio, we automatically detect and snapshot and record what you did and the results that you generated. So here's that experiment I ran. Domino detected the plots that were generated. We detected the summary statistics that got produced. And now this is hosted centrally. So this makes it really easy to collaborate. I can say, you know, would NLTK be better? And if someone, we talked about shared context, collaboration, discussion. So now if someone joins this project or a manager wants to get a sense of what's going on as the project's progressing, they can pop in and see that discussion organically. This also gives you reproducibility because we know if someone's looking at this result set months in the future, we actually know exactly where this came from. We know this came from experiment number 7. And I can say, oh, I tried, that was the one I did with the parameter 730. If I want to get back to exactly what produced that result set, I can get back to the version of my files exactly as they were when I ran it. And now if I'm wondering, you know, how is that better or worse than the latest version of this model I've been developing, I can actually compare my ideas, compare my experiments, and see not just source code changes, but complete results side by side. And so from the data scientist perspective, we got a productivity boost, but the organization as a whole got preservation of knowledge, reproducibility. And this is all just one project. If I zoom out here, we have all the projects that everyone's working on across the organization in one place. And so I can see what other people are doing. I can see that someone's doing some analysis right now on a credit default risk project. Someone could see that I'm working on this Reuters NLP project. And if someone is going to start some new work and wants to see, you know, what have we worked on before that might be relevant? Have we ever done anything with the Reuters data set? There's my projects. If someone's wondering if we have any examples of using NLTK, I can do a search. And I didn't find any projects, but you know, I see that there's been some discussion about whether NLTK would be better for a past result. And if we wanted, this will index sort of all the files and everything too. If you want to find code snippets you could borrow that might give you an example to start with, so you don't have to go learn everything from scratch. So that's how we accelerate experimentation and we enable collaboration. So I've kind of covered here was the workbench and this collaboration hub. I just really want to quickly talk about publishing and deployment, and I want to be mindful of time here. So let's say you built a great model, you built a great analysis. How do you get it connected to the business now? There are a few ways to do this. The first is it's actually really easy to set up things to run on a scheduled basis. This can send reports or recompute dashboards or notebooks that get rendered for other people in your team. One of the things, there's a bunch of other things I can show, but in the interest of time, one of the sort of the real engineering accomplishments we're particularly proud of is an ability to deploy predictive models as production grade APIs. And the way this works, where's my, I know I'm jumping a bit here. So we talked about development, workbench, collaboration, and I'm kind of quickly rushing to tell you a little bit about the whole other side of this around deploying models as APIs. And in the first half of 2018, Carlo may not know this, we did a complete rebuild of how we do this to make it sort of production grade, enterprise grade. And basically the idea is we'll let you take your Python or R model you built or any Python or R function you've written, and with a couple of clicks, you can sort of package it up in a container. We will make sure that the same packages are installed there that you used when you developed your model, all the versions are right. and then we'll deploy it across a horizontally scalable infrastructure. We will enforce access controls, we'll audit and version control every time a new model is deployed. We'll put load balancing in front of that, and we'll log all the requests that come in and the responses that go out. And just to kind of show you a quick example here, this is since I did the last thing in Python, I'll do this in R. This is a really simple R function that loads a model we've trained in a previous step. And I've got a function here called API. It takes parameters as arguments. Those parameters are a map or a data frame that have different properties of iris species we measured. We try to predict what species it is, and then we return the predicted species classification canonical machine learning data set. And I've already, if I want to publish this as a model, it's really easy. I can click on this publish section here, and it's just basically 2 clicks. I say, my code is in a file called api.r. This could be whatever your script is that you've already written. And here's the function. This could be, predicts credit score, predict probability of a maintenance event if you're in manufacturing, whatever. In our case, it's the API was the name of the function. And I hit publish, and we do everything I showed on that previous step. We productionize it, we stand it up. I've got it running already. I don't want to wait for it to publish. I just want to show you what it looks like. So now you can sort of pass in a payload as JSON, and we will marshal that into your function. So we'll marshal this data structure into the R code or the Python code and this little tester UI, and then we get back a response that's whatever your function returned. So my function returned a species prediction, and that's what comes back in the API request. And it's low latency, high scalability, high availability. We generate code snippets you can use to invoke this from other languages. So now you can turn any R Python code into a microservice, a web service that your production apps can use. You can do lots of nice things here. You can scale how many instances this is deployed on. You can configure who has access. And every time you make changes, we'll keep an audit record of who did what. And we'll also log all the incoming requests and responses. So we can see, I just tested this here, and here's the response I got back. So that's kind of the idea. Full data science lifecycle development all the way to deployment in one place that gives you best practices. It took a little longer than I planned. I'm going to be mindful of time. Let me pause and see if there are any questions. And would love it if if this looks interesting, please check us out. We've got a good blog where we write about this stuff too. So I can take questions now, or I can stick around afterwards as well.
Yeah. Anything is not going to disappear, but if you have questions, feel free to ask right now.
Yeah? Okay. Thanks, guys.
So, hello, everybody. Okay, I'm busy. What is the other one? Battery died. There's another one.
So you can shut on that.
Yeah, I can try to shout for a couple of minutes. Okay, so
Yeah, literally batteries. Well,
predicting the thing.
there we go. Let's see if we're good at things. No, we're not good at things. They're always good at things. No, these are not the right ones, Gianmario. These are the small ones. We need the big ones. So either we have big ones, or you need to shout. Start shouting. Start shouting out.
So my name is Alberto Rigoni. I've been working for a couple of years at Pirelli in Carlos Group. And today I'm going to be talking about how we have integrated Domino and Plotly for smart manufacturing application development and deployment. So you may not know this, but Pirelli has over 20 different manufacturing sites all over the world. They're mainly located in Europe, but also China and South America and Mexico. So basically, it's a lot of data that is flowing to the headquarters here back in Milan that needs to be analyzed. And so we moved to smart. Carlo mentioned before smart manufacturing. So smart manufacturing is often connected to the Industry 4.0. I'm not sure if you're familiar with this definition, but we got this from Wikipedia, and it draws a parallel between the fourth industrial revolution and Industry 4.0. So basically, we're going from after the introduction of computer and automation into the factories. The factories themselves are becoming now cyber physical systems. So Carlo mentioned machine-to-machine communication and self-regulating factories. And so Industry 4.0 features a lot of different technologies, but we have been concentrating on big data and analytics, which constitutes a layer that sustains some of the other layers, probably all of them, and in particular, the industrial Internet of Things and security and the cloud itself. And so I may switch to Google Drive. That's just the resolution of I'm just going if we can see it, I then switch back to Google Drive. Cool. So as I was saying, this is Pirelli vision for smart manufacturing. So it features three different sequential steps, and they're sequential in time and complexity. So we can start from the first, which is real-time analytics. We need to go from the acknowledgement of something that happened yesterday to something that is happening right now. This is the real-time, and we need for this advanced data mining to create data products. So basically, a data product is anything from a very simple, basic web application to something more complicated as predictive modeling, which is the second step. So predictive manufacturing is, which is building and deploying models that can forecast product quality, for example, from process data. For this, we need predictive models and algorithms. This is the step Carlo was talking about. This is where we are at right now. And moreover, we have the third step, which is prescriptive manufacturing. So using machine-to-machine communication, this allows for process tuning and resource allocation, these three steps contribute to the vision of the virtual factory that Carlo was talking about before. So it's not only real-time analytics and data that we are seeing right now coming from the factories, but it's also about self-regulating factories, which allows, as I was saying, for process tuning and different resource allocations. This is a very high-level overview of the architecture for smart manufacturing at Pirelli. And so we have data flowing from the factories, you see in the lower part of the slide. We have data ingestion step. So data is flowing back to our data lake and is stored in the Hadoop cluster that we have in the headquarters. So as I was saying, we have data coming from the factories, but we also have a centralized infrastructure VPC that we use in the headquarters. And all this data is used, it's centralized, and we use it for training machine learning models to produce analytics. And once the data products are created, and they can be deployed back to the local servers of the factories. We also have a smart learning notification system, which we call ICAP, which is part of the second category of data products that I'm going to be showing later. I actually have a couple of examples of this. And so data products development follows two different and parallel lanes. So we have fast prototyping, which is, well, these are the technology, this is the tech stack that we use for fast prototyping of applications. We have Domino, Jupyter, and Blockly. And this, we use control user groups to provide a fast iteration loops where we can add features. We can add, so we can we use these iteration loops to bring the products from concept to prototypes that we can directly deploy on our infrastructure. You can see on the right side of the slide. The technology that we use is slightly different. We also have, well, we use GitHub Enterprise for version control, Python, Blockly, and Domino, and then for front-end development, Angular, JS, although we're kind of switching to React. And so these are the two different parallel lanes for applications development that we use. And so we have to, we can detect two different, we can split data products into different categories. The first category is for KPI visualization and analytics. And this is like the simple kind. And in this, the data is human interpretable. We have small volume data, we have straightforward KPIs that we can identify. And this is basically descriptive analytics. We have a couple of examples of this, but still, so the bottom line is that the action is triggered directly from the visualization that we're going to get from the data that is flowing. And the second category of data products is smart alerting. In this case, data is no longer human interpretable because it's large volume, and we cannot identify straightforward KPIs. So we need machine learning algorithms and more advanced analytics. So basically, the action is no longer triggered by the simple visualization, but it's, the action itself is triggered from the algorithm perspective, from the machine learning algorithm. And so the visualization is still retained and is used to interpret the results that we're getting from the machine learning algorithms. And so this is like to put things in perspective. This is where data products are going when they're created. And this is very messy and noisy environment. And this is basically a 52 inches display that it's, this is where when we deploy data products, and this is just to put things in perspective. I'm not sure which factory it is. It's probably a factory in Romania, but still, this is it. So I'm moving to the first example of data products. So remember the two different categories. The first is just visualization, the triggers, the action. The second category is the machine learning algorithm that can produce, that can trigger the action, and that visualization is just used to interpret data. So this is the first kind. And so the goal, so as I was saying, machines in factories are organized in different production lines that contributes to different stages. And the process time for a single tire on the same machine for the same product should roughly be the same. So if we can find a discrepancy of cycle time of a single product on a machine, we need to detect it. And this is a very simple application. So we analyze process time discrepancies on different machines, and we fit density distribution on cycle time data. As I was saying, so the goal is the detection of discrepancies between different distributions. And this is the visualization that we are using to detect this kind of discrepancies. So the analytical part is very simple. We are using a co-multiplier a divergence metric in order to rank them. But apart from this, we are merely showing that there is a divergence, and the people from the factories need to go there and try to understand where this anomaly was generated. So the results are ordered according to the discrepancy that's been calculated between the distributions, and this application has been deployed on Domino. We created a custom launcher, and so it goes off every time. At each time of day, the workers in the factories are warned about an eventual anomaly. And so, as I was saying, machines in factories are organized in different production lines at different stages. And if this is the case, we need to have KPIs that are calculated for the tires that have been produced. These tires also need to be traceable. Now let's pretend for a second that we only calculate just one KPI for a single tire that's been produced. What we'd like to know is a trend that we detect for that KPI and by a product category. We don't want to a KPI to go like out of control, and we need to know as soon as we detect that particular trend where it was originated from. And ideally, we would like to have it as early as possible in the production line. So let's try to see, this is also a very simple application. We just need to detect a one-dimensional trend in a time series, basically. So this is an example of trend detection. An alert is sent every time a trend is detected, and this Python code that performs this operation is running a Domino. So it renders a report for decision support, and the graph was produced using pandas, but we're going to see now. So this is a time series that we are dealing with. So for each KPI, we can identify trends using a sliding window on a relative basis. So we have different batches of 4 hours, and an analysis is run every hour. But at this time, when we were designing this pattern test, it was like one of the first tests that we produced for smart manufacturing applications in Pirelli. We were facing a difficult decision because R has a lot of great packages for time series analysis, and R is, well, it's great in general and for statistical analysis, and we were using that for a lot of things. And at the time, we were using also Python for infrastructural needs, and also there's SciPy, NumPy, Mathlete, Pandas is great for data wrangling. So we were, but it doesn't have a lot of support for time series analysis, and this is also true today. And so we were facing the choice. We had to re-implement everything from scratch, or we could have just used R. Fortunately, thanks to Domino, we could write, and this is very similar to what Nick was describing. We could write a code in R, and this code was deployed on Domino, which then in turn exposes an API that Python, a client Python, can access. So this is all for message passing and object conversion. I can also show you a very simple snippet. So this is all it takes to write a trend detection test. in R. It's very simple. But this is also the code that it takes to run on Domino and to expose the API to the Python client. So this is the man-candle test for monotonic training in a time series, and there's a package for that in R, as it often happens. And we run it on Domino, and Domino exposes the API that can be contacted by using a Python client. I was using here Request. There's probably a custom Python client for Domino, but we could just use curl, for example. And so what we're passing here is as parameters JSON is a very simple time series. And the response is the trend p-value of that segment, of that batch that we are analyzing. And if we need to have something a little bit more complicated, we take a look at different parameters all at once. So remember, we were pretending we just had one single KPI for a tire, for every tire that was produced. In reality, we have like dozens of different parameters and KPIs for every single tire that were produced. So we need to implement an anomaly detection system. So basically, anomaly detection is very relevant for smart manufacturing. Basically, we need to classify new data as similar or different to the training set. And we are using batch model training, which happens once a week, on some reference data, which constitutes the in-layers data set. And we were using a machine learning model. It's also very simple. It's one class SVM with a radial basis function kernel among the different algorithms for anomaly detection that exists. And so we had a machine learning model that was working and was identifying anomalies, and then we had to display the same results for interpretation to the users. So we'd like to just not identify the anomaly in some process parameters, but we want to label the process overall as an outlier. So we're just showing the normalized reference distribution for process parameters on the training set. And then we can just show the, and it's not showing, but we have an inlier as classified as such, and an outlier, and we can just pinpoint the single parameters that were detected. And this is a little bit of a digression, just one slide. But so the smart manufacturing team has been training a lot of people around the world. 130 people were trained in the factories, and they were trained from exploratory data analysis to the deployment of a web app using Angular JS. And the technology that was the key to this training was Domino that we use extensively, and also Python and Flutter. So basically, we would like to provide tools for data exploration to factory faults. And this was very effective. We got a lot of prototypes. So some of those prototypes were then later brought to production. And so this is the final slide. It's a bit of a summary of what we talk about here. And we have discovered that visualization plays a big role in factories as means to convey key information to the workforce in the field. And so we have to be using fast prototyping and fast iteration with control groups of users in the exploratory phase before bringing that to production. We are combining the output from algorithms and machine learning models into interactive web-based visualization to be used in production. This is for the future. We need to expand towards predictive and prescriptive manufacturing. So thank you very much.
So thank you very much, Nick. So we went very quickly through the two talks. We didn't. So this is the time for questions. So if you got any questions for Nick, Alberto or Carlo, then don't be shy. Yes.
Hello, I had a question for Alberto, and I was interested to know how do you get the data from the shop floor? Because a factory is a living animal, so there is always something changing on, and you have to guarantee consistency of data at the time. So I would be interested to understand how you get the data to build the model. Thanks.
So the smart manufacturing team has a lot of different people involved. This is not only data scientists or data engineers. So the basic answer to that is the fact that we have a lot of different people from the factories that are using that are producing that kind of data. And of course, it's really hard to have reliable data. It requires a lot of insights, and we have a lot of engineers working on that, and we are actively collaborating with them. So basically, as you have seen in the high-level overview of the infrastructure, we have a lot of data that's flowing into a central, into our central storage, which is also the data lake. We're exploring constantly different kind of solutions like S3 and different databases that are maintained by a lot of people. So it's online. It's a very difficult question, but to ensure reliability of the data. But we need to have people inside the data science support team that know what they're doing, and basically they're the same people who are working in the factory and try to ensure reliability of that data. I'm not sure if that answers, but
because they are those people that are going to use the insights you provide.
Yeah, sure. That's so smart
cycle.
Yeah. So the one of the good aspects, or more or better, the aspects I like about smart manufacturing is that you can have fast validation of the algorithm that you're producing, and even validation for exploratory data analysis, like in real time. You can call it just the person and have the answer you're looking for.
Any other questions?
Question for Nick. Is Domino available for free, or maybe do we have plans to make some of the features available, or it's just for business?
Good question. Thanks. We have a cloud environment that we host and manage, and we make that available to students and hobbyists. But for commercial use, if you're sort of using it for your work purposes, then we charge for that. And you can do that in a version, an environment that we can host, or we can also run that in your own environment.
And in the environment available for students or hobbyists, is the API feature available or not?
It is, yeah.
Okay, thank you.
So just keep in mind that after this event, we'll send a follow-up email with all the references, links. So you will get access to all this, everything we we'll see now.
And we have also time during the visit or drinks and bits.
Yeah. And also everyone will be here after the tour of the museum, so you can speak and make now. There are other questions? We've got a few extra minutes. Okay, so thank you very much. So now there's going to be a couple of guides from the museum. They will split into groups and we'll go visiting, and then in around 40 minutes, 45 minutes, we'll be here. We will prepare the buffet for the aperitif.